So in the section 5.5, we study a technique to find an integral. That is called the substitution rule, based on the chain rule. So if f prime is equal to small f here, then integral of f prime of g of x multiplied g prime, it will be f of g of x plus a constant. So, and if we make a change of variable, or we call it substitution, we replace g of x by u, then the integral becomes integral of f prime of u du. In this situation, we need to find the relation between du and dx. Okay? Or if we write capital F prime as small f function, then we have this relation here. Can you see it clearly? And for definite integrals, so the integral from a to b of f composite g times g prime dx here becomes integral of f of u du, but the limit is changed. Here, the limit b will become gb, and the lower limit here, a, becomes ga here. So be careful with this. So in short, you need to change everything in terms of a new variable u here. So keep that in mind. And another properties in this section is that the symmetric properties. It is very nice. It allows you to compute an integral over a so-called symmetric limit from negative a to a. If it is an even function, then this integral is 2 times of integral from 0 to a of fx dx. Or if it is an odd function, then the area upper the x-axis and lower x-axis will be the same and they cancel each other. So the net change of it is simply 0. This is very convenient for us if we are given an odd function, which is very complicated, and use this properties quickly. Okay? And here is a very simple example. Let us go through it. And we play with this single example to remind ourselves every properties in this section. First, if we need to compute the indefinite integral of this function, right? And we see it's very complicated. So we observe that here is a square root of something here. And in the numerators, there's an x dx. The trick here is to do substitution. If we define u as 1 minus 4x squared, right? Then we need to find the relation between du and dx. Simply, we take derivative both sides. The derivative du over dx on the left-hand side will be derivative of negative 1 minus negative 4x squared, which gives us, wait, there's a mistake here. What do we have here? Yeah, negative 8x. Yeah, there's a typo here. This is negative 8x dx here. Okay? Do you all see it? Then we see that in the original integral, there is a term x times dx here, right? So we can replace x dx by du, right? And how can we do that? We divide both sides. Very good, yeah. Then we see that x dx, we can write it as negative 1/8 du. So now let us replace this original integral, okay? And we rewrite this function as 1 divided by square root of 1 minus x 4x squared times x dx here, okay? Now we write everything in terms of u. So it becomes integral of 1 over square root of u, and x dx here is negative 1/8 du, right? Then the constant, we can take it out of the integral sign here. It means it becomes negative 1/8 integral of u to the negative 1/2 du. Now, we need to find the antiderivative of u to the negative 1/2, which is 2 square root of u. Okay? So look at that. Is it clear? If there's any question, just ask me up to this point. How about people on Zoom? You follow?
It's clear.
Looks good to me.
So now, let us compute it. And remember, we need to find the most antiderivative. Therefore, we need to add a constant c here, right? Very good, where c is a constant. So, but we're computing the integral in terms of x. What we found here is in terms of u. So we need to do one more step. We replace u by the terms we defined before. So we have everything in terms of x here, right? And keep in mind, the indefinite integrals give us a function, right? Or more precisely, it is a family of functions depending on a number c here. Okay? The same story. If we need to compute the integral here in a definite intervals, then we do the same thing. We repeat the process, but but we need to find the limit in terms of u, right? So be careful. The same story, we define u to be 1 minus 4x squared here. Then the same story, it will be negative 8x dx. Therefore, x dx becomes negative 1/8 du. And in terms of x, the interval we are computing, this integral is from 0 to 1/2, right? But now we need to compute in the new variable u. If we make a change of variable here, then the interval will also be changing. So at x is equal to 0, right? We need to find the corresponding value of u, which is 1 minus 4, 0 squared. So it's simply 1, right? And here, when x is equal to 1/2, we have u is 1 minus 4 times 1/2 squared. 4 times 1/2 squared give us 1. 1 minus 1 give us 0. So the bounds, if x run from 0 to 1/2, u will run from 1 to 0. It doesn't matter which way we are running, right? But we know that, okay, we change the limit and 1/2 becomes 0 here. 0 becomes 1 here. Okay? We don't care much. We just know the corresponding values. Then the same story. We find the antiderivative of this guy, which is negative 1/8 times 2 square root of u at u is equal to 1 to 0. U is equal to 0. Okay. Then negative 2 times 1/8 give us negative 1/4. And the upper limit here is at 0, right? We replace u by 0. Subtract the lower limit here, where u is equal to 1, which give us negative of negative, give us 1/4. Is it clear? It is a very good question. In this case, the definite integral gives us a number, right? And from here, we found that, okay, this is the antiderivative, evaluate at the value from 1 to 0. We can substitute the value directly here. Or if we use the previous example here, we do substitution for a long time and finally we got this result. Okay? But x will run from 0 to 1/2. Okay? Yes, as you can see, x run from 0 to 1/2. Then we substitute the value of them here. It will be negative 1/4 multiplied with a difference of 1 minus 4 times 1/2 squared minus square root of this guy. This gives us the same result. Okay. It's a very good question. Thank you, Gary. So is it clear? If we're computing definite integral, we can replace the value right here and it saves us a little more time. But computing the indefinite integral, we need to find everything in terms of x because that is the original question. Okay. So, are we good? Good job. I hope that with this notes will help you memorizing the topic, the idea better. And we play with this example again, but we need to compute the value of this integral over the interval from -1/2 to 1/2. Okay. Whenever you see an integral like this, ask yourself if we can use some symmetric properties to save our computation, okay? In order to check if it is odd or even, we need to evaluate the function f at the value -x, okay? If we define f of x is the integrand here, then let us find f of -x. It means the input here is the -x. We'll replace x by -x, which becomes this guy, right? Divided by square root of 1 minus 4 times -x squared. Okay? When we do so, we see that -x here, we can take the negative sign in front of the fraction here, and the denominator -x, and then raised to the power of an even number. It is the same as x squared. So again, we see that this guy is nothing else but the function f of x, right? But in front of that, there's a negative sign. Oops. So therefore, we conclude that this function is an odd function. Okay? If it is odd, then the integral of this, you can imagine like this. We are computing two areas which cancel each other. They are the same, but they cancel each other. Integral from this interval gives us 0. Okay? Are we good? So from these properties, if we separate the integral here into a sum of two integrals, integral from -1/2 to 0, plus integral from 0 to 1/2 here, right? In the previous example, we found that, okay, this guy is 1/4. Okay? And just right here, we found that this integral is equal to 0. So, therefore, the integral from -1/2 to 0 will be -1/4. Okay? This is a consequence. Or you can compute this integral again and double check if you got the same result as here. Okay? So that is all we need to study about this section. Do you have any question? No, you don't have to. You don't have to compute the integral from -1/2 to 0 here. I just want to point it out for you to understand. Oh, because this is a properties of an odd function. So we can conclude that, okay, this guy is equal to 0 immediately. But what we need to do is to prove that this function is odd. Okay? Otherwise, if it is even, we need to compute it clearly. If it is even, then it is 2 times the integral from 0 to a. But somehow it will be easier to compute. Okay? Very good. Anything else? And then we have a list of similar problems. In the test 4, if I give you problems, I will pick one of these. But now in class, let us pick a random question and do it together. Okay? Which one do you want me to do together here? The first one, okay. Very good. The first one, there's a hint there already, right? We want to compute this integral. It is not easy to find the antiderivative of e to the 5x, or you can find it if you do it many times. But let us make our life easier by changing the variable, okay? In the hint, if you define u to be 5 times x here, what does it mean? What is du? Yeah, you compute du over dx, right? Or you prime compute derivative both sides. The right-hand side will be d over dx of 5x, or it is 5. Therefore, imagine that you multiply both sides by dx. Right? Then these two, imagine that you can cancel it. Or in short, we say that, okay, diff u is 5 times dx. Okay? Very well. If we know the relation between du and dx, and in the problems, we want to write dx in terms of du, right? So how can we do it here? Yeah, we divide both sides by 5. Therefore, du divided by 5 will be the right-hand side divided by 5, give us dx here. Okay. Ramin, can you see it? Is that okay? Is it okay now? Vikram? Very good. So let us write everything in terms of u. Okay? We know that 5x is u, so it becomes e to the u, multiply what here? Yes, du over 5. Very good. Thank you, Michael. And the integral here, if you see the constant and numbers, get rid of them by taking it out of the integral first. It makes our life easier. Okay? Now, e to the u du. It is a name, right? So what do we have? We need to find the antiderivative of e to the u here. Yes, e to the u. Thank you, Matthew. Is it enough? Yeah, plus a constant, right? Where that constant is a number in the real lines, or we can write it in notation here like this. That's it. Or do we need
you?
Yeah, you have to put 5x back in.
Very good. That is what I was about to ask. So we found the antiderivative in terms of u, but what we need to do is to find the antiderivative in terms of x here, which means it becomes 1/5 e to the, remember, yeah, 5x, yeah, be careful. Thank you. Was it Daniel?
Yeah, and Garrett.
Garrett, okay.
Thanks.
You're welcome. Thank you, everyone. So that's it for this problem, okay? With integral, it is easy to check. Suppose we are in the exams and we don't know if our computation is correct or not. Then in that case, we can double check it by taking the derivative of the right-hand side, right? To see if it becomes the same as the integrand here. Okay? If they are the same, then we are confident with our result. If not, there's a mistake somewhere. Okay? Let us do it. Let us check it. Now we need to compute the derivative of 1/5 e to the 5x here plus a constant derivative. Okay. Derivative of a sum will be the sum of the derivative, and the constant, we can take it out. Therefore, it will be e to the 5x derivative plus c prime. Okay. So, what is the derivative of e to the 5x? It is the derivative of the power here times e to the 5x. Remember, there's a formula, so double check it. And the derivative of constant will give us 0. So now it is 1/5. Derivative of 5x give us 5 e to the 5x. 5 cancel with 5 here. Therefore, it is e to the 5x. Okay, that's it. And it is exactly the integrand here. Then we are good. We're confident with our result. Okay? Is there any question? Very good. which one do you want me to do? Want us to do together? So which one? Number 5, okay. Very well. Now, somehow they're related to each other, right? And when you do it many times, you know that changing the variable in this way would give us our life easy. Okay? If we define u, or let us rewrite this integral first. Integral of x to the 5, if we write it here is x squared, x square root of 1 plus x squared dx here, right? We'll see that derivative of x squared gives us x. Okay, so if u is 1 plus x squared, then what is du? Very good, 2x and dx, right? Or let us write it slowly. Du over dx is 2x. Therefore, du is 2x dx. Okay? And in this original integral, we have the term x dx here. Okay? So, therefore, du divided by 2 is x dx. Okay? Oh, yeah. Then, what should we do? Here we have x squared. But our definition is x squared plus 1. What should we do now?
U plus 1.
Close, but remember the sign. Yeah. From here, if we subtract both sides by 1.
Yes, U minus 1.
Yeah. So it means that we can write x squared as u minus 1, right? Very good. So therefore, the original problems is x squared and then square. So let us write x squared, right? Square root of 1 plus x squared x dx. We just rewrite the original problems. So, and x squared is u minus 1. We replace it here, right? The power, we just rewrite it. Here, u, square root of u here, right? And du over 2, right? Be careful. So now everything is written in terms of u. So the constant here, let us take it out to make our life a little bit easier. So what should we do next? Any suggestion? Louder, please. Yeah, we are finding the antiderivative in terms of u, but this is a product. It looks complicated, right? Can we make it simpler? Very good. We expand this perfect square first. Thank you, Gary. So u minus 1 squared is the same as u squared minus 2u plus 1. And all of them multiply with square root of 2u, square root of u, or let us write it as u to the 1/2. And then du, right? Okay, very good. So now, what should we do? Yes, distribute it, file it, and you see the number is here, integral u squared times u to the 1/2 minus 2u times u to the 1/2 plus 1 multiplied u to the 1/2 du, right? Okay. It will be the integral of a sum of u to the something. And each of them, we can compute it easily. So what is it here? U of 2 times u to the u squared times u to the 1/2. Very good. It is u to the 5/2 minus 2 times u to the, very good, and yeah, u to the 1/2 times 1. Okay. Remember, we need to compute the antiderivative of these things. So use the parentheses. If you don't use the parentheses, they may have a mistake. So we need to compute each of them here. What is antiderivative of u to the 5/2? Yes, let us do it slowly. U to the 5/2 at 1, right? And remember, antiderivative, we add 1, but then we need to divide it by this power, okay? Which is 5/2 plus 1 here, okay? So that when we take the derivative, these numbers will cancel each other, okay? That is the reason. The same story. Here, -2, u to the 3/2, we need to add 1 here. Then divided by this power. The same story is u to the 1/2 plus 1 here. 1 divided by 1/2 plus 1. Okay. And what else? Yes, very important. So let's say number C, where C is in R. Okay. So this is 1/2, and 5/2 plus 1 give us 7/2. 1 divided by 7/2, it means, yes, 2/7 due to the 7/2 minus 2 times, this is, yes, 2/5 due to the 5/2, and very good. Right. Very good. But now we found the antiderivative in terms of u. We want to write it in the original variables, right? The x variable. And as we defined, u is x squared plus 1. Therefore, this guy becomes 1/2, 2/7, and x squared plus 1 to the 7, and the square root minus 2. Is it clear? We can stop here, or sometimes we can simplify it to get rid of the number 1/2 here, make our computation looks nicer. Okay. We distribute this guy here, distribute here, and distribute here. Is it clear? Very good. So go home and follow the same steps to do these examples in the notes. And I'll see you tomorrow. See you, everyone. See you. You too. Bye-bye.